Okay, so we already went over inverse operations, and so now we will use those inverse operation concepts in solving equations. Okay, but first, to just really understand what we do on one side of the equation or one side of the equal sign, we must also do on the opposite side or on the other side. So here is an image of a like a weight scale or a balance beam or an equilibrium, right? Where if the weights are equal on both sides of this beam, then it is going to be straight and balanced. So here, as if we have an equal sign here and we have, for example, 10, and the other side is x plus 2. Okay, so just in understanding why we would have to perform the same operation on one side, we would also do the same to the other side. So we would apply the same rule in the other side of the equation, right? So if it is balanced on this side and this side and it's both equal, then our line will remain straight. Now, if it's too heavy on one side, like say, for example, if it's too heavy here on the right, the weight will go down and this will kind of shift up. And vice versa. If it is the opposite, where it is heavy on this side will go down and this side will go up. So we want to always make sure that our weight on both sides is equal so that the line remains straight. And so if not, then it'll teeter-totter up or down on either sides depending on where it's heavy and where it's light. And so that's just one of the reasons why we want to always perform the same thing that we do on one side of the equation, we also do on the other side. So here in this case, our goal is to isolate the variable x. In doing so, we would have to figure out what is the inverse of adding, and the inverse of adding would be to subtract. And so in this case, we're going to subtract 2 here. And so since we subtracted 2 on the left side, we must also subtract 2 on the right side. Okay, so to again maintain the balance and make it equal, now we have 2 minus 2. This is equal to 0. 10 minus 2, this is equal to 8. Okay, and so now we have x is equal to 8. If I substitute the value of x, which is 8, into the original equation on the top, and we input 8 here, 8 plus 2 is equal to 10, and we have 10 equals to 10 on both sides, and therefore our balance beam, our equilibrium, stays balanced and stays leveled. It remains straight. And so that is a demonstration using the balance beam and why we would have to apply the same operation on one side. We would also have to apply it on the other side.